Hello everyone. Welcome to the solution of LeetCode problem 107 named Binary Tree Level Order Traversal 2. In this problem, we are given the root of a binary tree and we have to return the bottom-up level order traversal of its nodes value from left to right, level by level, from leaf to node. So here the root is 3. It has two children, 9 and 20. 20 also has two children, 15 and 7. Now here 15 and 7 is the last level. So we have to return 15 and 7 first. Now after that, 9 and 20 is the second last level. So we have to return 9 and 20 here. Now 3 is the first level. So we have to return 3 here. So this is how the level order traversal we have to return. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, we have taken this example. Here the root is 5, which has two children, 3 and 6. 3 has one children, 1 and 2. And 2 also has two children, 1 and 1. Now, how can we solve this problem? As we have to find the level order traversal from top to bottom. That means we have to return this level first. After that, we have to return this level. After that, we have to return this level. After that, we have to return this level. So, to find the level order traversal from top to bottom is little bit of complex. Instead, we can find the level order traversal from bottom to top, and we will simply reverse the order and we will get the answer. And if any kind of problem, we have to deal with the sum of the level orders, we will simply use the breadth first search technique. It is a popular graph algorithm which search a graph or tree into a level by level order. So now, in the BFS, we will simply store or take the advantage of the queue data structure, and we will take two of the vectors. One is the final vector to store the answer, and another is the temporary vector. Now, initially, we will start the DFS from the root 5. So, we will insert 5 into the queue. Now, what is the size of the queue? It is 1. So, we have to insert the top element 5 into the vector, temporary vector. So, it is here. Now, 5 has a left and a right children. So, we have to insert 3 and 6. Now, here, before that, we have to insert the vector 5 into this resultant vector. Now, the top element of the queue is 6 and it has two children, 1 and 2. So we have to insert them 1 and 2 here. Now let's see this 5 here. So we will store 6 into the temporary vector. Sorry, we have to store 3 into the temporary vector, which is this. Now, these 3 and 6 comes from the second level. So now our top element is 6. So we have to remove this and insert 6 into a temporary vector here. Now 6 does not have any of the left and right children. So we have to store 3 and 6 into the vector, which is the second level. Now our queue has 1 and 2, which is the third level. So we have to remove these 3 and 6 from the temporary vector before that. Now we have to add 1 into the temporary vector, but 1 does not have any of the left and right children. So we don't have to add anything here. Now we have to pop 1 from the queue. Now we have to consider these two and insert these two into the queue. We have to remove it, and after removing, as 2 has the left and the right children. So we have to insert both of them into the queue. Now we have to insert the temporary vector which contains the element 1 and 2 into the vector. Now the third level is processed. Now let's process the final level, which is 4. Now the top element of the queue is 1, so we have to remove it and insert 1 into the temporary vector. Now 1 does not have any of the left and right children, so we have to simply remove it. Or we don't have to insert anything into the queue. Now the top element of the queue is 1. So we have to insert the 1 into the vector and we have to add this temporary vector into the corresponding final vector. Now let's see. These 5 corresponds the first level. These 3, 6 correspond the second level. This 1, 2 correspond the third level, and this 1 and 1 corresponds the fourth level. So now this vector is the representation of the all of the level from top to bottom. But in the question, we have to determine the representation from bottom to top. So if we reverse this, we will get 1 and 1 as the first vector, 1 and 2 at the second vector, 3 and 6 at the third vector, 5 as the last vector. So here, this list of vectors or this list of arrays is the bottom to top alignment of this tree. Or we can say that this is the bottom to top traversal formation of this tree. And this is how basically we're going to solve this problem by using the breadth first search technique. I hope you understood the algorithm. Now let's move on to the code. Here we are given a function named level order bottom, and which is a root as a parameter, which is a tree. Now we are taking answer vector, and if the root is null, we have to simply return empty vector. Otherwise, we are taking a vector queue. Sorry, it is a queue named queue, which will take the tree node as a parameter. Now we are inserting the root into the queue, and we are running this loop while the queue is not empty, and we are calculating the size of the queue. Now we are taking a temporary vector current, and we are running this inner loop until the size of the queue is 0. And here we are storing the front element of the queue into a variable x, and we are removing the front element, and we are inserting its value into the current. And here, if the front element has a left subtree, we have to insert the left subtree into the queue. Similarly, if it is a right subtree, we have to insert the right subtree into the queue. Finally, we have to return, or we have to insert the current vector to the answer vector. And we have to reverse the answer vector. Finally, we have to return the reversed version of the answer vector. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.